All right, hello, welcome to another lesson from Chapter 9, Inheritance. Before we dive into the main part of the lesson, just got a warm-up question. This is a sample AP level question with an array. Pause the video, give it a shot before continuing. Okay, so we've got a while loop here, we've got an array, and I would almost always on the AP test or any test really label these indices. So we've got 0, 1, label the spots, I should say, 2, 3, and 4 in the array. Okay, so those are the positions for the given values, the indexes. Okay, and so I is going to be the index, I think, right? It looks like it's an index. And we're going to loop while we're less than the length. That's good because we don't want ever I to get 5 or 6 or something because we get array index out of bounds. But also while this sum stays below the limit. So the limit starts at 3 and never changes. So it kind of makes sense that our answer, well, actually we could eliminate 1 right away. What is the value of I? Actually, I don't know. So we got to look more closely. I'm not sure if we can eliminate any of them yet. But I starts at 0. So I'd make a little table here. I starts at 0. Okay, and I would do sum. Sorry for the bad handwriting here, but sum would start at 0. And we've got limit, which I think is always going to be 5 all the way through. Not 5, 3. Sorry, limit just stays 3 all the way through. Okay. So sum is sum less than limit and I is less than length. But this first time through, oh yeah, sum is less than limit, it's less than 3, okay, and I is less than the length. Okay, so we go plus plus I, so it would be 1. And then sum is going to be whatever sum was before, which is 0, plus the ith spot, which is 2 at this point. So sum is now 2. Okay, so sum is still less than the limit, and I is still less than x dot length. So we're going to come and do plus plus I, we get 2. Okay. Oh, actually sorry, the first time sum added position 1. So this should have been 1, sorry. Because I was 1, so we added position 1. So that was a 1. I had that wrong. Okay, so now we're going to add position 2 to our sum, which is a value of 4. So this is going to be sum, which is currently 1, plus the value of 4. So this is now 5. And I think the loop will end now, because sum is no longer less than the limit. So I will end on 2. I believe that's right. Okay, so in today's lesson, we're just going to keep going with the questions and quiz project. All right, and we did a question already. We did a multiple choice question. And then we've got 2 left, true, false, and numeric. Okay, and then obviously, as we discussed before, there's a separate quiz file that has main, it has the runner, and all where the questions are created when you make instances of them. And then, yeah, we got that going. We got a couple questions working on that, hopefully at this point. Whoa, what am I doing? Okay, so we got the quiz off here kind of as its separate deal. So in today's lesson, we're going to go over a numeric question, all right, and see if we can create that class and then make an instance of it in quiz. All right, so here's again what we already built in question. I know they're maybe named a little bit, like this is called display question, but basically these are the methods and variables that are in question. So what's going to be different in numeric questions? Pause the video and figure out which of these methods have to be different. All right, so I think the main difference down here is going to be we're going to have a private data variable that's a double or an int, depending on if we want to allow double answers or just int answers. But I think let's just do double. So that's going to be answer. And I'm not sure we really want to call it answer, call it the same thing. So maybe we'll call it like numeric answer. In fact, I'm not sure they're going to let us call it answer because then we'd have 2 answer variables in this class because remember all this stuff flows down. So let's call it numeric answer. And then the methods that are going to have to be different would be like the set answer and the check answer. All right, because we're going to be dealing with doubles now instead of strings the way these are set up. I think the rest is the same. We display the text because the question would just be like, what is the cube root of 47 or something, right? And then we just need to change these methods. Okay, so I'm going to add down here what we need, the other parts. So I'm going to do a public Boolean check answer. And then we're going to have double user's answer. Okay, and then we're going to do a public void set answer. That needs to be different with a double new answer coming in. All right. So those would be some methods that we need to make different. And then all the other functionality we can just use from question. One thing I did want to point out, out on Schoology, you should find a PDF with directions, right? It's quiz program directions. And I didn't give this to at first because I thought it might be a little overwhelming, but kind of the big picture is we want to get 4 functioning questions, like of each type. We have question, multiple choice question. We have those done already. We want to get a numeric question and then a true false question. Okay, so it kind of goes you through step by step. And we've already did part 1, 2, and 3. And let's see, we're on part 4 now, numeric question, right? But this is a good guide for you. And actually, this one, we want to do it so that when they do check answer, it can be off by like 100th and still be counted as correct. So basically, if it's in the ballpark, we're going to count it as correct. So that helps me figure out that I do need to use doubles here. Okay, so I'm going to use doubles, not ints, for my set answer and check answer. So at any rate, this document's out there kind of to guide you, and I haven't referenced it all the time because, like I said, it'd be overwhelming. These videos will more or less walk you through it, but I just wanted to point out that there's a guide here that'll kind of help you. Yeah, so let's do numeric question. So we got our quiz program here, right? And I'm going to make a new one in the same package called numeric question. And if I didn't make this clear before, this is going to represent one that has a numeric answer, like 5 or 7.8 or something like that, versus a string as an answer. Okay, so let's do our instance variable, the new one. Oh, and actually I forgot something already. Right, so actually you do this, right? Try to program it. If you haven't already, try to program it based on what we were talking about in here, right? See if you can do some of that program before continuing. All right, so first thing is I forgot we should do extends question because it's going to be a subclass. Think of that hierarchy. All right, and then I'm going to make a private double, and I'm going to try this once to see if I can call it answer or if it's going to be mad about that. Amazingly, it doesn't seem mad because I would guess that question. Oh no, I have correct answer. Okay, so let's see if I can call this correct answer. Okay, and it's still not complaining. That's surprising because I feel like that would be 2 variables that are in correct answer. But anyways, let's just call this one numeric answer just to keep it differentiated. Okay, and then the constructor. Okay, and if it helps you here, think about like quiz, right? Like here's what it looks like when we create a question in quiz. All right, so ours is going to be very, very similar with only one minor difference for this numeric question. All right, and that difference is this going to take in an int here instead of a string, right? Because this is our text, and then this is the correct answer, right? So I'm going to do public numeric question. All right, this is my constructor. This word public, and it has to match exactly the class name. And I'm going to do string the text in the question text. And then I'm going to need to do, let's see, a double answer. Okay, and so kind of the simple thing is I can set the numeric answer variable just to be whatever's coming in. All right, and so the text is going to be kind of trickier, right? Because well, actually, I think I'd have some options. No, actually, I don't know. So I need to set this question text right here, but it's private. Okay, so I can't access it directly. All right, maybe that's why it wasn't complaining when I used the same variable name here. But anyways, so I can't just do like that. That would be nice. Okay, so my options would be, let's look at what we have available. I could call this constructor I could call super and call this constructor, but I don't really have a string answer. I could just make it blank, I guess, and not use it. Or I could just call set answer. Maybe that's the easier way. That'll just set it that way. So let's just do that since that's what we really need to do. So I'm just going to call super dot set answer to be the answer coming in here. No, not set the answer. I need to set the text. What am I doing? Set text to be the text that came in. Okay. I think that should be okay. Numeric. Oh, should be numeric answer. Sorry, I'm making piles of answer mistakes here. All right, and I think that should be it. I don't know why it's still complaining yet. Implicit is undefined. Let's explicitly invoke another constructor. Honestly, I'm not quite sure what that error is getting into there. Well, it might. Maybe we have to call the super constructor. Maybe. What if I do super text in and then just a blank string there? Wonder if it'll be happy then. Let me try that. All right, so I guess it wants me to use the super constructor. So this is the answer part of it, which is just blank. Okay, so let's see. That was kind of a pain. That was trickier than I would have guessed, to be honest. But I've got my private variable. Now I just need to overwrite check answer and set answer. Okay, so I'm just going to add those in here. So I'm going to do public Boolean check answer. And then I'm going to take the user's answer, right? This is the answer that they've supplied, and check it against the one that is stored inside of this class. Okay, and like I said, the difference can be, like I could just do equal equal if they're equal, but I actually want to do the difference, right? So, because it can be off by a little bit. So I'm going to do the user's answer minus the actual answer. And if they were exactly right, you'd get 0, but they can be within 100th. Okay, so what I'm actually going to do here is I want to basically check if the diff is within 100th. So if diff is less than or equal to 100th, then it counts. Right, so then I'm going to return true that they're equal, else I'm going to return false. All right, so I'm going to subtract the user's answer from the actual, and if it was 0, I'm perfect, or anything less than or equal to 1/100th, I'm okay. Okay, and the only problem here is if they guessed lower than the numeric answer, so to be as clear as possible, let's say they answered 9, okay, and the actual answer was 9.0001, right? Then it's going to give a negative number. And actually, a better example of this, maybe if I did like 13, so the difference here would be -4, but that is less than the amount that we're allowed. Okay, so really what you need to do to handle this is you need to do the absolute value, right? So I want to do math.abs so that if they enter something that is, if their answer is below the actual answer, then it'll still count it as wrong if it's off by more than 100. So to handle that case, you have to do the absolute value. Then this will evaluate to 4, not -4, and then it'll return false the way it should. Okay, and then I'm just going to do the other one real quick here because I'm running low on time. But my final one is I just got to do public void set answer, which I might never really use, to be honest, again, but it's going to pass in a new answer and set the numeric answer variable here to be that new answer coming in. All right, so I think that should be it. In the next video, we will go over creating one in Quiz and getting it to work. So thank you for watching.